Hi everybody, this is Mechanical Engineering by Hand, and today I'll be talking about horsepower. In a previous video, we talked about work in foot-pounds, and power is work per time, so foot-pounds per second. And then horsepower is foot-pounds per second over 550, or if you're dealing with minutes, foot-pounds per minute divided by 33,000. So let's look at an example. Let's say we have a 10-ton load that we want to raise with a hoist, and we want to raise it 30 feet, and we're willing to wait 2 minutes for it to raise that load up 30 feet. So our horsepower, since we're dealing with minutes, we'll use this equation. Horsepower will be 30 feet per 2 minutes times the pounds. 10 tons would be 20,000 pounds, and then divided by 33,000, and that equals 9.1 horsepower. And that would be the power required at the load. It doesn't include any inefficiencies in the hoist. Another example would be a gear, and let's say it's spinning at 1800 RPM, and we have a 500-pound force from another gear or a pinion, and then our radius of the gear is 3 inches. So we need to find the velocity of this point where the force is applied, and once we find that, we have the force, and we're using minutes, so with that information we should be able to determine the horsepower. So velocity at that point is going to be 2 pi times r, which is 3 inches. We'll divide that by 12 to get feet. Now this is the circumference, and then we multiply that times rotations per minute. Gives us feet per minute, and that is equal to 2827 feet per minute. Okay, and then the horsepower, we'll use this equation. Plug in our numbers, 2827 feet per minute, and multiply times the 500-pound force divided by 33,000, and that equals 42.8. All right, one more example, similar to a gear. Let's say we have a pulley being driven by a belt, and we have a 100-pound force on the tight side and a 50-pound force on the slack side, and we're spinning at 300 RPM, and we have a 1 foot radius. Okay, I'm going to go straight to horsepower equation. Plug in our numbers. We're dealing with minutes, so we'll use this equation. Feet per minute, the velocity would be 2 pi times 1 times the 300 RPM. So 2 pi, I'm going to leave the 1 out of there, times 300, and then our force will be the net force of 100 minus 50, so times 50 pounds, and divided by 33,000. 33,000, and that equals 2.86 horsepower. Now, an equation when you're dealing with foot-pounds and RPM, an equation for horsepower you may have seen is RPM times the torque in foot-pounds over 52, and you can see that our torque is here, 50 times the 1, I left the 1 off. RPM is here, and then 2 pi divided by 33,000 is equal to this 52. So that's where that equation comes from. It's just 2 pi divided by 33,000 is the denominator, and then you have RPM and torque in foot-pounds. So thanks for watching the video. Please let me know what you think in the comments.